Until I graduated, I didn't understand the principle of the electric motor, but it turned out to be so simple. If the teacher had taught me this, I would have gotten into Harvard. When we hold two magnets in our hands, they interact with each other. That is, opposites attract and opposites repel. Then we hold one of the magnets, drill a hole in its center, and insert a shaft so that it can rotate freely. When another magnet is brought close to it, the magnet with the hole drilled in it will rotate rapidly until they are attracted to each other by their opposite polarity. If we then change the direction of the magnet on the shaft will rotate half a turn again because of the repulsive force. And as long as we don't get tired, we can keep changing the direction of the magnet so that the magnet on the shaft will keep rotating. Next, we got a piece of bolt, wrapped it around a couple of coils of insulated wire, connected the ends of the wire to a power source, and the bolt became an electromagnet. The same phenomenon of opposites attracting the same poles repelling occurs when we bring the previous magnets close together. If we exchange the positive and negative poles of the battery, the polarity of the electromagnet will flip accordingly. But it is too much trouble to exchange batteries back and forth. Then we will try to switch the connection of the wire. The same can be realized N-pole and S-pole switching. We similarly drilled a hole in the center of the bolt, inserted a shaft, and energized the coil, and the bolt would rotate half a turn because of the magnet interaction force. As long as we don't get tired of constantly switching wires, the bolt will continue to rotate. But we didn't want to get tired yet, so to save energy, we changed the magnets on both sides to a curved shape and replaced the wire wound bolt in the center with a metal circuit we called an armature. The armature will also start spinning as soon as power is applied, but manually switching the wires will still tire you out. So we turned the wire connection points into curved pieces of metal separated by a slit in the center, which we call the commutator. The sides of the commutator are then fitted with brushes, which have springs inside to ensure that the wires make contact with the commutator. When the brushes are energized, the comb starts to rotate, and the brushes switch contact points after passing through the slit. Since there are two brushes switching on both sides at the same time, if the current in the armature flowed in this direction before the switching, then the current will be in the opposite direction after the brushes switch the contact points, meaning that the polarity of the electromagnet is constantly switching to keep the comb continuously rotating, just as if we were manually switching the wires so that we don't get tired of it. However, the speed of electric transmission using only one coil of wire was not smooth enough and was prone to lagging. In order to improve the efficiency, we added more armatures to it and installed more commutators so that an electric motor was made. In order to improve its service life, we also added a fixed device. This is the principle of the motor used in our daily life. Isn't it very simple? Do you know how to make it?